Alright guys, so let's start talking about Chapter 8. What questions or issues did we have dealing with geometric transformations? So dealing with translations, and we don't get to dilation until Chapter 9, but we deal with rigid motions here. All things that change where the shape is, but not what the shape is or the size of the shape. Questions from 8. Anything from 8.1 dealing with just translations. How we shift things horizontally or vertically or both. Any questions from 8.2 dealing with reflecting? It's easiest if you go straight over the x-axis or straight over the y, but you can reflect on any line. You can even reflect on diagonal lines. It makes it a little bit harder. Questions on 8.3, dealing with rotational concepts. I gave you a little cheat sheet there. Remember that when we're rotating in the positive direction, it's counterclockwise. Anything from 8.3? No? I thought the geometry chapters might be a little easier. 8.4, when we compose... So can anyone remind me what composition of isometries means? That's a really fancy way to just say something actually not that fancy.
Isn't that like a multiple rigid motion?
Yeah, multiple rigid motions. So if I slide right, then I slide down, that would be a composition of isometries. If I translate, then reflect, or reflect, then translate, that's a composition of isometries. Okay, and then that's it. So we have no questions from Chapter 8? Sweet. Let's just move on to Chapter 9 then. So I know I have a couple from Chapter 9. So 9.1 starts with perimeter and area in the coordinate plane. So we use our distance formula there to figure out lengths of things. From there, I can use that to solve perimeter or area. Any questions on 9.1? I'm going to go remind the people in the library that we're now moving on to 9 because they might have thought that 8 was going to take a minute.
Hey guys, we're moving on to Chapter 9. So if you have any issues with the chapter, now there are 2 questions now. So Chapter 9, come on in if you want.
I have this.
Sweet. You can just put it in. That's all. Just the top one's fine.
I wasn't sure if it was this.
Not during the summer. 9.2, areas of parallelograms and triangles. And the fun part about parallelograms is they're really just 2 identical triangles. So that's where we derive that formula there. Nothing from 9.2. 9.3, areas of trapezoids, rhombuses, and kites.
I'm actually looking on 9.1.
9.1, all right, let's back up.
It's kind of weird with the homework answers. For this one, it says it's 28.
For which number?
Number 1.
Number 1?
It says it's 28, but I've put 9 times 5. 9 times 5.
What's it asking you to find?
Oh,
It's all good. We all make those mistakes sometimes. So perimeter, I would do 9 plus 5. That would give me 14. I would double that because I have another length and another width, and that would give me 28.
Okay.
Notice also when you're checking with the answer key, it probably says 28 centimeters, not centimeters squared. So you know if it's an area problem, the label has to be squared. So that should be an indication of, wait, if the area or if the answer is not squared, it's not discussing area. So now you had questions from 9.3, didn't you?
Yeah.
Was it you, Liam? Yeah, I
had,
thought.
questions. I think it was 22 or something.
So isn't it the... Actually, I gave you guys 29, 30, and 31. The rhombuses.
Yeah.
Yeah. I am gonna snapshot this really quick.
Hey, Mr. Hudson,
Mm-hmm.
are you recording are you recording 8 right now? Doing
8 was so quick. I'm still just recording. It's just one continuous right now.
Can I ask you a question afterwards?
Yeah, I mean, is it about 9 or is it not about 9?
It's not about 9.
Yeah. Alright, so we start with this. But from there, we can look at each one of these individually. Now notice it says that we can leave it in simplest radical form. Anytime it tells me simplest radical form, you should be thinking, now why might they tell me leave it in simplest radical form? Well, special right triangles here allow me to create relationships that inform me of my unknown lengths. Because notice that on each of these, you're given one length and one angle measure. So, like I mentioned in Schoology, if we look for our special right triangle rules, we can find a pretty easy, these right here are what we need to deal with. So, I'm actually going to put this over in my smart file because of course this will all be uploaded after class. So, can you compare these two special right triangles with the three shapes you have and make any kind of connections? Or what's one thing that we know about rhombuses? Well, if I can't remember, we know that each of these is a rhombus. So what, and I'm still trying to always help you guys know how to search things up. What if I just want to remember what are properties of rhombuses? Rhombus is a flat shape, 4 equal straight sides. Opposite sides are parallel. Opposite angles are equal. The diagonals of a rhombus bisect each other at right angles. The diagonals of a rhombus bisect each other at right angles. That statement right there is huge. What does it mean to bisect each other?
They split into.
They split each other in half. So what that tells me is, crap. I need to plug in my smartboard. Sorry. If I want to write on this, it would help if I was plugged in.
Wouldn't that mean that if you have one side, you have them all?
Yes, but unfortunately, solving the area of a rhombus is not as easy as like the area of a rectangle.
Sorry.
So, yeah, that does mean that if I know that this is 6, then I know that this is 6, and that's 6, and that's 6, and this might catch up, or it might need a minute to initialize. But does that help me find the area? Well, if I go back to our Schoology page and check what we had posted for the 9-3, like the initial things, here I have area of trapezoids, here I have area of rhombuses. Now wait, the easiest way to find the area of the rhombus is by knowing both of your diagonals. And this property comes to us from knowing that these are two triangles that are both congruent on top and bottom, and we can build this whole proof that shows us why this works. We could also break it up and have a longer way to solve the area by dealing with triangles and their altitude. It's like the base and the height, and then the other base and the height. But that would be difficult because I would need this base, and then I'd have to continue the line out like a dotted line to find the height of that triangle here. And I would do the same thing. It would be the same height for the other one. It's just a long process. So this is the easiest formula. Once I know both diagonals, the product of the diagonals, then cut in half, is your area. So, do I know these diagonals? No. But what I do know is all my edges. Could you relate a special right triangle rule and knowing those edges to help us solve this problem. I'm hoping
It's like the second right triangle rule, the one on the left.
this one.
It has 60 degrees and so does this one.
It's got 60 degrees and so does this one. Because what we know is in a triangle, if I've got a 30 degree, a 60 degree, and a 90 degree, my shortest side will be opposite my 30. My middle side will be opposite my 60, and my longest side will be opposite my 90. In a 30, 60, 90, the way to remember this is 30 and 60. Well, 30 is half of 60, but be careful with that trick because the side that is opposite 30 is length x. The side that's opposite 60 is not your 2x. It's the side that's opposite your 90 that is your 2x, and then this is radical 3 times x, or x times radical 3. So I got to get my smartboard to work. If I tell it I'm using a pen. Might need to stop this video while I get the smartboard fixed.